All right, so let's continue on here with example 4. And let's start with finding the EVs. All right, so let's set these denominators not equal to 0. If you solve this one right here and you take the square root of both sides, x cannot equal 2 minus 1. So that's for this first denominator, x squared minus 1. X plus 1 can't equal 0. That's my second denominator. X can equal negative 1. And then last but not least, 2x can't equal 0. 2x can't equal 2. X can't equal to 1. So notice these kind of overlap. And so at the very end, you can just be combined. X can't equal to plus or minus 1. Okay, so if you have an excluded value that's listed multiple times, you just need to list it one time. All right, so how do we proceed with this problem? Again, I would use the LCD method. Okay, so this one, the work might not be obvious. So let's figure out what the LCD is here on the side. For the first denominator, this is different two squares, x plus 1, x minus 1. The second term's denominator is just x plus 1. And then the last term right here, if I factor a 2, I have x minus 1. So if you remember how to find LCD, right, you see if there's any factors in 3 of the terms, and there's none. And then you proceed to see if there's any common factors in 2 of the terms. So right here, I see an x plus 1, that's common. I'm going to cross off and use it once. X minus 1 is also common. I'm going to cross off and use it once, and then multiply by what's left. What's left is this 2 right here. So this is your LCD. And using the LCD method, right, I want to multiply the whole equation by the LCD. So over here, I'm going to write it here on the left. So it's 2 times x plus 1, x minus 1, and distribute the whole thing. Over here, you can factor your denominator if you want. So I'm going to write x plus 1, x minus 1, plus 2 over x1. Sometimes it's just easier to see what cancels out if you factor it. So I'm going to do that. All right, so this is my LCD. I'm going to distribute to the whole equation. All right, so step by step, if I multiply the LCD by this first term, notice the x plus 1, x minus 1s will cancel out. And the only thing that's left is a 2, and so it's going to be 2 times x. If I distribute LCD into the second term, the x plus 1s will cancel out. So if the x plus 1s cancel out, 2 times 2 is 4, and you still have x plus 1 that's left over, okay? And last but not least, if I distribute to this final term over here, the 2x minus 1s and the 2 times x minus 1s will cancel out. You're just left with an x plus 1, okay? All right, so proceed here to solve by combining like terms, distributing, simplifying. It looks like you just have a nice linear equation over here. So 6x plus 4 is equal to x plus 1. If I move the 4 over, I'm going to get 5. If I subtract x over here, I'm going to get x. And x is equal to 1. All right, so remember, after you get your solution, right, make sure it's not part of your EVs. And actually it is, right? This solution right here is an EV. And so if it's an EV, right, you have to exclude it because x can't equal to positive 1. So even though we got a solution of x is equal to 1, we know it's going to make our denominator 0. So I'm going to cross this off and say no solution. All right, so that's pretty much the idea of solving rational equations. State your EVs, solve by multiplying the whole equation by the LCD, and if your solution is part of an EV, make sure you exclude it. So for these next two examples, once you understand the concept, you can just try these problems on your own by pausing the video and see if you come up with the correct solution. Okay, so example 4 or 5 will be a try. And example number 6 will also be try. Okay, so just take a few minutes just to try working on this problem on your own. And then also, let's see, work on example 6 when you're done. In fact, let me just put it right here. Example 6, 7 over x minus 3 is equal to x plus over x minus 3. Okay, so try these two and see how you go. Okay, so assuming that you paused the video, try this on your own. Let's take a look at the first example. Let's start the EVs. We're going to set this guy right here, 0. All right, so it looks like we have a nice factorable trinomial, w minus 4. W plus 1 can't equal 0, so w can't equal 4. w can't equal negative 1. And then w minus 4, our second denominator, also can't equal to 0. W cannot equal to 4. So notice these two are the same, so you just need to list it once. So your overall E's are w equal to 4 or negative 1. All right, so the LCD of this problem right here is just w minus 4 times w plus 1. Okay, so let me show you the work here on the side. This is w minus 4 times w plus 1. And w minus 4, right, you can't factor it. So the LCD, if you use this once, w minus 4 times w plus 1. That's what you've got for your LCD. Distribute. All right, so if you multiply this term times this term, right, the multiplied trinomial of this is already just w squared minus 3w minus 4. And I'm multiplying by w. When you multiply this term times this term, right, this is essentially w minus 4 times w plus 1, right? These terms will cancel out entirely when you distribute into the second term. What's left is a w plus 7. And last but not least, when you multiply this LCD into this term, the w minus 4s will cancel out. You're left with a w plus 1 times a w squared. All right, and then from here, right, distribute, combine like terms, and simplify. All right, so you're going to get w cubed minus 3w squared minus 4w plus w plus 7. Over here, you're going to get also w cubed plus w squared. These w cubes will cancel out. Let's move all the terms over to the right side of the equation. When we do that, we add 3w squared. We're going to get 4w squared. If we combine these two terms, right, that's a minus 3w. If we move it to the other side, it becomes plus 3w. And then plus 7 becomes minus 7. All right, so try to factor and solve over here. It looks like this is factorable. 4w and w, and then factors of 7 that give us 3. How about we use 7 and 1? So how about we have a minus 1 here and a plus 7. So again, you could check, right? This is 7w, this is negative 4w. 7 minus 4 will give you w, okay? All right, so 4 plus 7 is equal to 0. You should get w equals negative 4ths. And w minus 1 is equal to 0. W is equal to 1. Now, at the very end, make sure you check that none of these are EVs. Both of these solutions are not EVs, okay? So not an EV. So these solutions should check into the original equation, right? Our EVs are 4 and negative 1, but over here we got 7/4, negative 7/4, and positive 1. All right, so for the second one, right, this should go by a little bit quicker. The only EV that you will have is x minus 3 can't equal to 0. So x can't equal to 3. All right, so cross multiply. 7 times x 3 is equal to x minus 3 times x plus 4. Now, at this point, you might be tempted to cancel out the x minus 3s. I would just distribute, okay, because in general, it's not a good idea to cancel out variables when you're solving a rational equation. FOIL, you're going to get x squared minus 3x plus 4x is plus x minus 12. Okay, move all your terms over. You're going to get x squared, subtract 6x, and then 21 minus 12 is plus 9. All right, so this looks like it's a PST, right, for a trinomial. If you take the square root of both sides, you're just going to get no such thing as plus or minus 0, so I would check this. You're going to get x equal to 3. So again, this is actually part of our EV. And so if it is, right, we exclude it and we just say no solution. And that's pretty much it.